This video is an example problem for Professor Mokadam's construction layout and site development class. In this particular example problem, we're going to be finding the length and bearing of an unknown line, given the information shown here. We want to find the distance and bearing of this line between A and B, between these 2 points. What we have is a location of point A. We have its coordinates. We have a distance and a bearing between A and point C over here, but we do not know the location, the coordinate location of point C. We have a line between C and B. We know its bearing and we know its distance, but we also don't know the grid coordinates of point B. We can solve this pretty simply. It's all just triangles, but we don't have enough information as it sits now to solve this triangle because we don't know any of these angles. All we have are 2 sides. That's not enough to solve a triangle. We need some angles. How can we get those? Well, we can create more triangles. So let's see what we can do here. We have this bearing. We have to think about what that represents. It represents a deflection, essentially, from north. So if we assume, and we're going to assume, that the top of this page is north, then this direction going up there is north. What we can do is I can draw an imaginary line right here that is north. And so that means that that bearing tells us this angle. Let's go ahead and convert that into decimal just to make life a little bit easier. The way I do that is very simple. I like this method. There's other ways to do it, but I take 35 minutes, multiply by 60 to get that into seconds. I get 2,100. I add the 47 seconds that we already have, and I get 2,147 seconds. I need this to be in a decimal of a degree. Well, there's 60 minutes in a degree, 60 seconds in a degree. 60 times 60, 3,600. So I can take this 2147, that's 2,147, divide it by 3,600 to get the decimal portion of a degree that we have here. And then I can add that 58 degrees that we started with. So add the 58. So I get 58.596 degrees. Now that does not tell us the angle created in this triangle. This tells us the angle created between this imaginary north line and the angle, or the line AC. With that though, we can find something out. If we do another imaginary line here that is a north-south line, well, we know based on just the principles of how parallel lines interact with a line between them, and I'm not a geometry teacher, so this has some name, but I don't remember what it is. So if you have 2 parallel lines, if you have 2 parallel lines and then a line between them, well, this angle and this angle are the same. This angle and this angle are the same. Same with these here. All the A's are the same and all the B's are the same. Makes sense. So what we know is that this angle here is also 58.595 degrees. If we draw an imaginary line down here running east-west, well, now we've created a right triangle, because a north-south line and an east-west line are perpendicular. Well, if we know that there's 180 degrees in a triangle, we can go ahead and take 180, we can subtract the 90, because it's a right triangle, gives us 90. We can subtract that 58.596 and get 31.404 degrees. We now have everything we need to either use the basic trig formulas, or I like to use law of sines. You can do this either way. You're just solving a right triangle now. I'm going to do it with law of sines because I like law of sines, because it works for all triangles, whether they're 90 degree or not. It's just a preference I have. You can do this however you want, though. So I've got enough information here to do law of sines. I can do 330, and I can divide that by sine of 90, and sine of 90 is going to be 1, but just to show it, we end up with 330. It's 330 divided by 1. Now we can multiply that by, let's go for this angle here, because we want to get this opposite side. So 31 point, or oopsie, sine 31.404. Catch me slipping there. So multiply by sine 31.404. We get 171.953 feet. And we can do the same down here. We'll do 330 divided by sine 90. It's going to be 1. It's going to give us 330 again. We can multiply that by sine 58.596. Looks like I wrote that as a 5 before. Oops. Sine 58.596. We get 281.6597, so we're just going to call that 660 feet. Well, now we know the coordinates of A. Still the screen, yep. We have the coordinates of A, so we know that it is at 20 north. Well, we have this distance here that is the north-south distance between A and C. So all we have to do is take that 20, add that 171.953, and we find that C is at 191.953 north. And our east-west is going to be very much the same. We have 65 already known that A is at 65 east. We're going to add this 281.660 and get 346.660. So now what we're able to do with that information is do, am I actually recording? Yes, I am recording. What we're able to do with that information is continue on to find the location of B. How can we do that? Well, we know where C is located. We have a distance and a bearing. So what we can do here is draw another imaginary triangle. Get that east-west line to intersect with this line here. We know that's a 90-degree triangle again, right triangle. So what can we do? What can we do? We gotta think about this for a second.